Today I am going to discuss about convergent sequence and theorems on convergent sequence. I'll discuss one theorem on convergent sequence. So theorem statement is, if sequence Sn is convergent, then sequence Sn is cauchys sequence. Same statement we can write in another form, that is, every convergent sequence is cauchys sequence. So what I am going to prove is, I will take one convergent sequence and I will prove it is cauchys sequence. Before going to this, we have to know what is convergent sequence and what is cauchys sequence. So convergent sequence definition is, for every epsilon greater than 0 there exists m belongs to z plus such that mod Sn minus L is less than epsilon for all n greater than or equal to m. So this is convergent sequence definition. So what is the meaning means, for every epsilon greater than 0, epsilon we will take, it's a very small positive integer. So we will take a small positive integer and there exists one integer, positive integer m, such that Sn minus L, Sn means your nth term. Suppose sequence Sn means, what we will define is some number of terms, 1, 2, 3, 4, so on, otherwise 1 by 1 or 1 by 2, 1 by 3, so on. So we will take some sequences. So in that sequences, so we will take nth term. So here it is 1 by n, otherwise here it is n. So that nth term minus this L is called the limit point. So if you subtract this nth term with this limit point, you will get a very small value. Why? Because I said epsilon is a very positive, small positive integer. So this value is less than epsilon. So basically it's a small positive integer. So this is very small. So we will say that sequence Sn is converges to L. Otherwise we will say that L is the limit point of sequence Sn. Okay, now I will write cauchy sequence definition. Cauchy sequence definition is also almost same of this sequence. Cauchy sequence definition is almost same. Here also, for every epsilon greater than 0 there exists m belongs to z plus such that mod Sp minus Sq is less than epsilon for all P comma Q is greater than or equal to M. So what is the difference between these two sequences means, here same we will take, for every epsilon greater than 0 there exists m belongs to z plus such that. So here we have taken nth term and limit point. So if we subtract these two, we will get a very small positive integer. So here what we will take is, here we will take some pth term, qth term, means suppose 1, 2, 3, so on, n. In the middle we will have some p and some q, some r. So this is all sp, sq, sr. So that's why pth term, qth term we will take. So sp minus sq is less than epsilon for all p comma q is greater than or equal to m. So these are the two definitions of your convergent sequence and cauchy. Why I discussed these two means? We are going to prove based on these two definitions only. Why? Because our theorem statement is every convergent sequence is cauchy sequence. Means we have to take this statement and and we have to prove this statement. In this statement only we will take this mod Sn minus L is less than epsilon, and we will prove that Sp minus Sq is less than epsilon. So basically epsilon is a small positive integer. So epsilon by 2 is also very positive in small positive integer. Epsilon by 3, epsilon by 4, so on, epsilon by n. Why? Because basically epsilon is a small positive integer. So obviously if we divide by 2, if we divide by 3, 4 or so on, these are values also very small positive integers. So what I am taking is, I am taking here proof. Now I am going to proof. So given what he has given, we are taking, given sequence Sn is convergent. Convergent sequence. Then I will write the definition. In this definition, a small change I will write. Every epsilon greater than 0 there exists m belongs to z plus such that mod Sn minus L is less than epsilon by 2 for all n greater than or equal to m. So what is the change I have taken is, in convergent sequence we are having mod Sn minus L is less than epsilon. Here I am taking mod Sn minus L is less than epsilon by 2. Why? Because just now I told you epsilon is a very small positive integer. Obviously epsilon by 2. Why? Because if we subtract these two, we have to get a least positive integer. So for my convenience, to prove this theorem, what is the theorem? Every convergent sequence is Cauchy sequence. To prove this theorem, I am taking in place of epsilon by 2. Okay, now I want to prove, we want to prove sequence Sn is Cauchy sequence. So what I am taking is, now for all some p comma q is greater than or equal to m. Why? Because I know in Cauchy sequence some pth term, qth term I will take. So that's why before taking that, for all I am taking some p value and some q value is greater than or equal to m. And now I am consider mod Sp minus Sq. Why I am considering this means, I want to get this is less than epsilon. If I get this is less than epsilon, I can say directly this is Cauchy sequence. So now what I am doing is Sp minus Sq equal to Sp minus L plus L minus Sq. Just I am subtracting and adding L. So if I cancel these two also, I will get the same term here. So that's why Sp minus L plus L minus Sq. This is less than or equal to mod Sp minus L plus L minus Sq. Why I wrote less than or equal to means, we already know that this is mod. Yes. So this is A and this is B. Suppose if you have mod A plus B, we can write it is less than or equal to mod A plus mod B. So this is my A and this is my B. So mod AB equal to less than or equal to mod A plus mod B. So the same term, can I write it as Sp minus L plus Sq minus L? Why? Because it is in the mod. So whatever you will get, negative or positive, you will get the positive only. Why? Because it is mod. So that's why I have interchanged the terms. So now Sp minus L is what? Sn minus L is less than or equal to epsilon by 2 means Sp minus L is also less than epsilon by 2, and Sq minus L is also less than epsilon by 2. So I'll write less than epsilon by 2 plus epsilon by 2. Here it is less than or equal to because of this formula, and here it is only less than because Sn minus L is less than epsilon by 2. Not equal to is not there here. So that's why Sp minus L is less than epsilon by 2 plus Sq minus L is also less than. This value we can write 2 epsilon by 2. These two will get cancelled. It is equal to epsilon. So therefore mod sp minus sq is less than epsilon. Therefore, we can say it is a Cauchy sequence. So, I have taken a convergent sequence. I got it is Cauchy's condition is also satisfying. So, I can write it as every convergent sequence is Cauchy sequence.